right, nerds, let's do it. Final time, or at the end. I'm going to go over some stoichiometry problems on here, and I'm going to give you guys some links for some more practice problems. If you haven't done these yet, you're doing this wrong. You right now need to try this out using your notebook. Make sure you have an answer, see what you're doing right, see what you're doing wrong. If you watch me give you the answer, you're not going to do that well on the test. Okay? But let's fly through this so we can get on with it. Okay? All right, reaction below. We have 40 grams of oxygen. How many moles of CO2 will be produced? Okay, so we're going from O2 to moles of CO2. Okay, we start with 40 grams. Whatever number's in your problem, that's what we're going to start out with. Label everything. This will help you out. Boom. We got 40 grams of oxygen. If that's oxygen in grams, this has to be grams. Okay, so boom, periodic table. Oxygen, 15.999, round to 1 decimal point, 16.0. We have 2 of those. 16.0 times 2 is 32.0 grams. That's our molar mass for 1 mole of O2. Okay, so we're going from grams to moles of oxygen, and then we're going to use our equation to figure out moles of O2. This is a 2-step problem. Okay. First step, this will tell us how many moles of oxygen. Next step, if this is moles of oxygen, this has to be moles of oxygen. Let's look at our equation. 2 moles of O2 for every 1 mole of CO2. Let's see what we get. Let's cancel some stuff out. Grams, moles of oxygen, moles of CO2. Because we labeled everything correctly, we know we're looking for moles of CO2. We're good. Let's type it in. 40 divided by 32. Okay. Times it by 1, times it by 1, divided by 2. And there we go. 0.625 moles of CO2. Circled. If your answer on your test is written in scientific notation, the answer has to be between 1 and 10. 1 place. 6.25 times 10 to the negative 1 moles. That's our answer written in scientific notation. Number dose. Reaction below, we have 6.45 moles of sodium bromide. Sodium bromide. This time we're starting with moles. How many moles of silver bromide will be produced? Okay, so now we don't have grams. We don't need molar mass. This is a 1-step problem. We're going from moles to moles. Okay, so we have a 1-step problem. We don't need molar mass. We don't need Avogadro's number. We don't need anything else. We're starting out with 6.45 moles of NaBr. If this is moles of sodium bromide, this has to be moles of sodium bromide. And if we look at our equation, 1 to 1. One of these for every 1 mole of silver bromide. That times 1 divided by 1 is the same thing. Our answer is the same, 6.45 moles. Done. Next problem. Reaction below. What if we have 3 moles of calcium carbonate? How many grams of CO2 are we making? Okay, we're going from moles of calcium carbonate. Moles can only be changed into moles of a different substance, so moles of CO2, and then we're changing it to grams. So this is a 1-2-step problem. Okay, always start with the number in the problem. We have 3 moles of CaCO3. Now we look at our ratio. We have a 1 to 1 ratio. This is easy. 1 CaCO3. That's how many we need. One of these to make one of these. 1 CO2. Mole. Mole. If these cancel out, this will tell us that we need 3 moles, or that we'll produce 3 moles of CO2, which is awesome. But we want to know how much it weighs. Okay? So now we need molar mass. Next box. If this is moles, this is moles. We now need to look up what the weight, how many grams of 1 mole of CO2 weighs. 1 mole of CO2, 1 carbon is 12, oxygen is 16, so 16 times 2 is 32. 32 plus our 12 from our carbon is going to be 44. CO2 weighs 44 grams. We're getting all those numbers from the periodic table. 2 of these, 16 times 2, plus our 12.01. All right, let's do some math. 3 times 1 divided by 1 times 44, okay, and divided by 1. So weigh 132 grams. Bam, bam, bam. There's our answer. We're good to go. Okay? So looking back at this, first one, we went from grams to moles to moles. Second one, we went a one-step problem, moles to moles. Third one, we went from moles to grams. Number 4. All right, we're actually below. We have 40 grams of zinc. How many grams of copper will be produced? Okay, we're going from grams to moles to moles to grams. Okay, this is a 1, 2, tree. It's a tree step problem. Coffee, so good, tasty stuff. Here we go. All right, so what are we working with? 40 grams of zinc. That's this guy. I'm going to circle it. It'll help me. How many grams of copper? This guy. 1-to-1 ratio. 40 grams. Okay. This has to be grams. I'm starting with zinc. Let's look up zinc. Zn. Boom, right there. Round it to 1 decimal point. 65.37 becomes 65.4 grams for every 1 mole of zinc. Okay. I've now converted it to moles. Now I use step 2. Step 2 is always, not always, anytime we're going from moles to moles, we're looking at our ratios in our equation. Okay, 1 mole of zinc for every 1 mole of copper. All right. Last thing we want, we now know grams. If I'm looking for grams, I have to convert it back. 1 mole of copper. 1 mole of copper, how much does it weigh? Back to the periodic table. We look here, 63.54. 4 means this stays the same. Rounded, this is 63.5 grams. Let's make sure we set it up right. Grams cancels out with grams. Moles, moles. Copper, copper. We're left with mass. Well, let's type it in. 40 divided by 65.4 times 1 divided by 1 times 63.5. And all right, I'm going to type that in again because I just wanted to be certain. But it looks like it's 38.8. 40 divided by 65.4 times 63.5. There we go. We will weigh 38.8 grams. In scientific notation, this is not between 1 and 10. It's too large of a number. 3.9 times 10 to the first power, because I moved it 1 spot. Graham crackers. Bam. Let's look at number 5. The reaction below, if you had 10 grams of hydrogen, how many grams of water will be produced? Okay, 10 grams of hydrogen, grams. 2-step problem. I'm sorry, 3-step problems. Grams to moles, moles to moles, and then back to grams. Okay, start with your 10 grams here. Put your molar mass of water here. I'm sorry, of hydrogen for every 1 mole. Over here, we're going to use our ratio. Looks like we have a 2 to 2 ratio, 2 to 2. Okay. We need to know the weight of 1 mole of H2O. So add up 2 hydrogens, 1 oxygens, molar mass goes here. Okay. 10 times 1 divided by your molar mass times 2 divided by 2 times your molar mass divided by 1 is your answer in grams. So do that. All right, let's look at 6 and 7. Using conventional factors, fractions, to determine the amount of products made in a reaction is called what we're doing, stoichiometry. Don't circle something else, okay? It's also dimensional analysis, okay? Both of these are acceptable answers. Converting is technically stoichiometry. Dimensional analysis is the actual math portion of doing it. When 2 substances react to form products, the reactants, which is used up first, what do we use up first? Okay, whichever one we're out of first is called our limiting reagent. Okay. Number 8, refer to the equation above. If you have 10 moles of hydrochloric acid, how many moles of CO2 will be produced? This is a 1, 2, 1, 1. Nope. This is a 2, 2, 1 problem. Okay. Start with 10, set it up just like we did all the other problems, and put answer. I'm going to give you guys another link to do more stoichiometry problem practice if you need it.